Right, so here's a question. If an AI diagnoses you with melanoma, would you want to know why it thinks that? Not just trust it blindly, but actually understand its reasoning? Because that's exactly what MIT just figured out how to do properly, and honestly, this one's got me thinking about trust in a completely different way. Welcome to Luma Digest Intelligence. I'm Noura, and today we're talking about AI that can show its working quantum physics that's actually useful for once, and why the smartest engineering teams are still investing heavily in human judgment. Luma, Richard, good to have you both here.
Good to be here, and yes, this MIT work is genuinely interesting. I've been tracking explainability research for a while now, and this is the first approach that doesn't feel like a compromise.
Right, because the usual explainable AI stuff is mostly theatre, isn't it? Makes you feel better, but doesn't actually help you make decisions.
Okay, so walk me through this. What's different about what MIT's done?
So concept bottleneck models have been around for a bit. The idea is you force the AI to explain its decisions using predefined concepts. Like in medical imaging, you'd define concepts in advance. Clustered brown dots, variegated pigmentation, asymmetric borders. Then the model has to use those concepts when making its diagnosis. Sounds sensible, right?
Except humans are terrible at knowing what actually matters.
Exactly. We think we know what features are important, but we're often wrong. Or we miss things entirely, so MIT flipped it. Instead of defining concepts up front, they let the model extract the concepts it's already learned during training. Then they use a multimodal language model to translate those internal representations into plain language humans can understand.
Wait, so the AI is teaching us what features matter, not the other way around?
Pretty much, and the results are striking. In medical imaging tests, this approach outperformed all the existing methods. Better accuracy and clearer explanations. You're not sacrificing one for the other anymore.
Here's what I like about this. It's not about making the AI smarter, it's about making the system more trustworthy. Because if I'm a doctor and this thing tells me it's melanoma, I need to be able to look at its reasoning and say, yes, I can follow this, or no, something's off here. That's the difference between a tool I can use and a black box I have to ignore.
Right, and that's especially crucial in high-stakes scenarios, healthcare, autonomous vehicles, financial decisions. Anywhere a wrong call has serious consequences. Luma, have you seen this pattern before? AI getting more transparent?
This is actually the third major explainability breakthrough we've covered this year. There's definitely momentum building, but this one feels different because it doesn't ask you to trust the explanation more than the prediction. The explanation is part of how it makes the prediction. That's architecturally elegant.
And commercially necessary. Every client I talk to wants to use AI for something important, but they all hit the same wall. Can we actually trust this? Can we explain it to regulators, to customers, to ourselves? This work gives them an answer.
Okay, so moving from transparency to something that sounds completely different but actually connects. Quantum computing. Now, I know, we've all heard the hype. Quantum this, quantum that, it's always 5 years away. But this week there were two developments that made me sit up and pay attention. Luma, you flagged these. What's happening?
So Harvard researchers demonstrated quantum entanglement doing something genuinely useful. They used it to detect optical signals so faint they arrive one photon at a time across a fiber link spanning over 1.5 kilometers. And the application here is optical telescopes with unprecedented resolution.
Wait, quantum weirdness is helping us see further into space?
Exactly. The same phenomenon that Einstein called spooky action at a distance is now a practical tool for astronomy. And at the same time, Columbia University showed you can control superconductivity by building a light-confining cavity directly into a material. No external light source, no magnetic fields, none of the elaborate setup that usually makes quantum experiments so fragile. You're engineering quantum properties into the material itself.
Okay, but help me understand why this matters. Because quantum computing has been the next big thing for, 2 decades now?
Right, so here's the shift. These aren't demonstrations of quantum effects, they're applications. The Harvard work could actually improve telescope resolution in ways classical optics can't. The Columbia work means you could manufacture quantum materials at scale instead of needing a physics lab to observe quantum behavior. It's moving from here's a fascinating phenomenon to here's a tool we can deploy.
I'm hearing the word practical a lot this week. Is that the theme? Quantum actually becoming useful?
I think so. We covered quantum security last week, quantum sensors the week before. There's an acceleration happening, not in the hype cycle, in actual deployable technology.
Which is interesting because it's happening quietly. No massive announcements, no billion-dollar funding rounds, just solid research solving real problems.
Right, okay, so let's talk about something that matters for anyone actually building things right now. Enterprise engineering teams, how they're using AI code generation. Because there's this assumption that AI writes code faster, problem solved. But that's not actually the problem, is it, Richard?
Not even close. Speed is easy. Understanding what you've built 6 months later, that's the hard part. Maintaining it when requirements change, that's where teams actually struggle. And AI-generated code, if you're not careful, makes that problem worse, not better.
So teams at IBM and other large organizations have documented 6 patterns to keep AI-generated code maintainable. And these are worth going through because they reveal something important about how production engineering actually works.
Go on then, what's the first one?
Explicit domain types instead of loose any types. AI loves to generate code that compiles but destroys type safety. It'll use string for everything. Any for complex objects. Technically works, creates a maintenance nightmare. So enterprise teams enforce specific types. A currency type that can only be USD, EUR or GBP. A payment request interface that enforces exact structure. This alone eliminates entire classes of runtime bugs.
This is the difference between code that runs and code that lasts. I've seen projects where AI generated the initial version quickly, then the team spent 3 months fixing type errors in production because nobody enforced this up front.
Okay, what's next?
Service boundaries. AI tends to write monolithic functions that mix database calls, validation, business logic, all in one place. Looks fine in isolation, becomes unmaintainable when you need to change one piece without breaking the others. So enterprise teams separate concerns, create an order service class that handles business logic, call that service from your endpoint, keeps things testable, keeps things readable over time.
And testable matters more than people think. If you can't test a component in isolation, you can't change it safely. Every modification becomes high risk.
Right, I'm seeing a pattern here. None of these are about writing code faster. They're all about understanding and maintaining systems over time.
Exactly. Third pattern is contract tests. AI code often works in isolation, but breaks during integration, so they validate API shapes. Assert that when you call an endpoint, the response has exactly the structure you expect. Small change, massive impact on production stability. Fourth is infrastructure as code instead of manual deployment instructions. CI pipelines that ensure deployments behave identically every time. Not glamorous, but this separates people who ship code from people who ship reliable systems.
And number 5 is structured code review with specific rules. Defensive coding patterns, checking for edge cases AI tends to miss. A function that sums an array, you need to handle the empty array case. Little things that prevent production failures at 2 a.m.
Okay, and the 6th one?
Observability baked in from the start. Logging, metrics, tracing. When something breaks in production, you need visibility. AI-generated code rarely includes this out of the box. You have to add it deliberately.
So here's my question. If all of these patterns are about human judgment, about understanding systems, why are we still talking about AI replacing developers?
Because the question is wrong. It's not about replacement. It's about what gets faster versus what stays essential. The typing gets faster, the boilerplate generation gets faster, but architecture decisions, maintenance strategy, understanding how pieces fit together, that still requires judgment. That's why these companies still invest heavily in developer growth pipelines, even as AI gets better.
And here's what I find interesting. These patterns aren't theoretical. They're documented by teams running systems at scale with real users, real money on the line. This is what actually works when you deploy.
Right, which connects to something else we looked at today, vector search. Because there's a similar pattern. Pure AI isn't enough. You need structure. Luma, break this down.
So vector search is everywhere now. Every semantic search tool, every recommendation engine. It works brilliantly for semantic similarity. Ask for comfortable running shoes. It finds products described as cushioned trainers or supportive athletic footwear. Understands meaning beautifully, but here's what it can't do. A customer searches wireless headphones under £80, not Beats. What does pure vector search return?
Wireless headphones at any price, including Beats.
Exactly. The price cap and brand exclusion are completely invisible to the embedding model. You can't encode under £80 as a direction in vector space. Not Beats isn't a semantic concept, it's an instruction. Every vector-only implementation has this blind spot.
Okay, so what's the fix?
A developer named Rafael Gron was building an e-commerce search tool and hit this wall directly. His solution? Add a second layer, an LLM parser that runs before the vector search. Its job is to decompose the query into structured components. So if someone searches organic shampoo without sulfates under £25, best rated, the parser extracts semantic query equals organic shampoo, price max equals 25, attribute exclude equals sulfates, sort by equals rating. Each component then goes where it belongs. Semantic query goes to vector search, price and exclusions go to database filters, sort preference re-ranks results.
That's clever. You're using AI to understand what the customer means, then using traditional database operations to apply what they said.
But doesn't the parser add latency? If I'm searching for blue t-shirt, do I really need all that processing?
Great question. Yes, the parser adds about 700 to 800 milliseconds, so he added a pre-filter. Simple queries skip the parser entirely. Complex ones with price signals, exclusion words, sorting preferences, brand names, those get full intent extraction. The routing is invisible to the user.
And this is the pattern again. Hybrid systems, not fully autonomous, not fully manual. The technology does what it's good at. Humans or traditional code handle what they're good at, and the integration is deliberate.
Which actually connects to something else we covered, human-in-the-loop AI workflows. Because the same principle applies. You don't want humans reviewing everything. That defeats the point. But you do want them involved at moments that matter. Richard, you've been thinking about this with clients.
Right, so imagine you've deployed an AI agent that drafts emails, updates your CRM, sends contracts, works flawlessly in testing. Then you deploy it to production, and suddenly you're explaining to your VP of sales why a prospect received a reply promising a 90% discount that doesn't exist. The technology is capable, but capability without oversight is a liability.
So what's the solution? Do you just review everything manually?
No, you build workflows where humans step in at moments that matter and automation handles the rest. There's a good playbook from N8N on this. 3 patterns worth knowing. First, inline chat approval. AI produces output, presents it in a chat interface, waits for a human to approve or revise. Works brilliantly for content review. Customer sends an angry email, AI drafts a response. Human reviews in chat and approves before it goes out. 1 click done.
Second is tool call approval gate. This is for agents. The agent decides it needs to update a database, send an email, call an external API. Before the tool actually runs, a human reviews the intended action and approves or rejects. So if the agent wants to send a contract before that happens, a human confirms. 1 wrong email, 1 wrong deal. You've sent a binding document to the wrong person.
And third is multi-channel review workflows. Not every reviewer lives in a chat window. Route approvals to Slack for quick operational stuff, Teams for cross-functional decisions, email for formal sign-offs. Set a timeout so workflows don't stall forever if someone misses the message. When the timer expires, escalate to a backup reviewer.
Okay, but how do you know where to add oversight and where to skip it?
You add oversight where stakes are highest. Customer-facing content, irreversible actions, novel inputs where the AI is operating outside its training zone. You skip oversight where speed matters more than safety. Internal drafts, reversible operations, things you can easily undo. And here's the key. You log decisions. Track your approval rates. If reviewers are approving 99% of outputs, that's a signal you can probably move to autonomous. If they're rejecting 30%, your prompts need work.
So the data tells you when you're over-reviewing or under-reviewing.
And this connects back to the enterprise engineering patterns. You're not trying to eliminate human judgment. You're trying to deploy it strategically. Same principle, different domain.
Right. Okay, last thing I want to touch on. There's a job listing that caught my attention. Eurocat's technology center in Barcelona is hiring for an AI robotics software engineer. And the requirements tell you something about where robotics actually is right now. Luma, you flagged this one.
Yeah, so they're looking for someone to work in their cognitive robotics group, building the robot's brain, perception, reasoning, planning, learning, natural human-robot interaction, real applications, assistive robotics, healthcare, flexible manufacturing, logistics, field robotics, not theoretical, applied R&D, and the skills list is revealing. Must-haves include Python and C++, ROS2, deep learning frameworks like PyTorch or TensorFlow, experience training and fine-tuning models, deploying AI on edge hardware like NVIDIA Jetson, building modular scalable software architectures.
And the nice-to-haves push further. Semantic perception, physical reasoning, world modeling, vision language models, vision language, action models, behavior trees, task planning. They want someone who can work independently and collaborate in multidisciplinary teams, someone who can occasionally support robot integration and field trials. Not a desk job, hands-on robotics.
So what strikes you about this? Because robotics has been the next big thing for a while too.
Here's what I noticed is this isn't hiring for a future that's theoretical. This is hiring for work that's happening now. Production-ready cognitive robotics. Real teams, real constraints, real impact. And the combination of skills they want, that tells you where the field is. You need classical robotics expertise, ROS2, control systems. But you also need modern AI, vision language models, behavior trees, edge deployment. It's a hybrid skill set for hybrid systems.
And the working environment matters. Permanent contract, hybrid model, flexible hours. They're competing for talent with tech companies. They know they need to offer more than just interesting problems.
Right. Okay, so looking across everything today, what's the thread? because we've talked about explainable AI, quantum applications, enterprise engineering, search constraints, human oversight, robotics hiring. They feel connected, but I'm trying to articulate how.
I think the thread is hybrid systems. Pure AI isn't enough. Pure human effort isn't scalable. The teams making progress are building systems where each component does what it's good at. AI explains itself using concepts it learned. Humans provide final judgment. Quantum effects become practical tools, not just phenomena. Code generation speeds up typing. Humans maintain architecture. Vector search handles semantics. Parsers handle constraints. Agents propose actions. Humans approve high-stakes ones. Robotics combines classical control with modern perception.
And the common pattern is transparency and structure. You're not asking people to trust black boxes, you're giving them visibility, control, and the ability to intervene when it matters. That's what makes these systems deployable at scale.
I think what I'm taking away from this is that we're moving past the hype phase. Not everything has to be fully autonomous. Not everything has to be pure AI. The smartest teams are building thoughtful integrations where technology amplifies human judgment instead of replacing it. And that feels like maturity. What do you think? Does that resonate with you? Let us know in the comments. We'd genuinely love to hear how you're thinking about this, especially if you're building these systems yourselves. Right, before we wrap, if you're enjoying these conversations, our newsletter lands in your inbox every evening, completely free. Just head to luma.marbl.codes. All the links to the stories we discussed today are in the description below. And if this is your first time here, hit subscribe so you don't miss the next one. We publish twice daily, and honestly, the community that's building around this show has been brilliant. Also, quick mention, if you're in the AI talent space, we're building a waitlist for Atlas AI talent. Early access spots are still available, links in the description. Luma, Richard, thanks for this. Really solid conversation today.
Always good. See you next time.
Cheers.